Yeah, tell me, what is the topic discussed in last class? Harshavardhan. Yeah, Harshavardhan is there.
Yes, sir.
What are the topic we discussed last class? You attended last class or not?
Sir?
You attended last class, Abba?
No, sir.
Why? Due to your came to college.
Yes, sir. Yes, sir.
Okay. Anybody else? Jai Surya. Jai Surya also, I think. Abhinav Gautam.
Yes, sir.
Yeah. What is the topic you discussed last class? I already shared the PPT to you. By seeing that PPT also, you can tell me what is the topic we discussed last class. Till what topic we have discussed. Yeah, anybody else? What is the topic you discussed last class? From girl side. Yeah, Abhinav Gautam. Yeah, Abhinav Gautam is there. Yeah. Previous class we had discussed about the IPv4 and then IPv6 and then what are the different types of subnetting process and then ARP, 4 types of ARP, 4 cases used in ARP. All these topics we are discussed in last class. Next topic we are going to discuss about the routing process, routing tables, routing algorithms. What are the routing algorithms are used in normal networks? What are the routing algorithms are used? And then by using internet, what are the routing algorithms are used? All these concepts we are going to discuss next topic. Okay, I will share the screen once again. Yeah, it's visible to all. The screen is visible.
Yes, sir.
Yeah. Okay. Yeah, we are going to discuss about today class is about many types of routing algorithm. First of all, what is unicast routing basis? Unicast means this is a point to point. It is also called as a point to point basis. This is used to connect the from source to destination. How they are connecting the data, how the data can be transmitted from source to destination. So it is a here example they are given as a G equal to n comma e. G equal to n comma e means n is assigned as a edge. Sorry, n is assigned as a node, which is assigned as a here nodes are u, v, w, x, y, z and the nodes. Okay, n is assigned as a node, e is assigned as a edges. So by using the two nodes, we are connecting the two edges. We are connecting the from one node to another node. That is called as a edges. So it is a, what are the edges? Set of links here connected means here u comma v is assigned as a one link, and then u comma x, and then v comma x, and then v comma w, v comma w, x comma w, and then x comma y, w comma y, and then w comma z, and then y comma z. These are the set of links used to connecting the all the set of nodes or routers in a particular diagram. So we are using here, for example, here the cost of path is assigned as a x1, x2 till xb, and then it is equal to x1 plus comma x2, and then x2 comma x3, and then like that it will go on process. Like c of x1 comma x2 is one node, and then plus c of x2 comma x3 as another node, and then third, if you are adding third one means it is c of x3 comma x4, and then this is the last node will be assigned as a next first node, next path will be assigned as a next path node. So the cost of cost will be w comma z. From w comma z means here w is assigned as a third node, which is z will be assigned as a last node. So in between the cost is assigned as a 5. What is the difference? We are combining these to u, v, w. This cost is 2 plus 3 equal to 5. So this equivalent cost is assigned as a w comma z. So this is a cost between the nodes between one node to another node, which is equivalent to that same cost. So based upon that, there will be a sharing of data between the networks from point to point connection or TCP connection. So here we are using the least cost path between the U and Z. What is the least cost path between the from source to destination? For example, source is assigned as a U, and then Z is assigned as a destination. Between these two nodes, what are the least cost? So we are going to find the least cost between the from one node to another node. Okay, here routing protocol, routing algorithm in the sense algorithm that finds the least cost path. Least cost path means there are different types of algorithm. We are going to discuss about the Digitas algorithm, link state algorithm, distance vector algorithm. Likewise, different types of algorithm we are going to see. And then for these algorithm is used to find the shortest path between one node to another. So by using the finding the shortest path between one node to another, it is used to by using the algorithm concept only, routing algorithm only, we can able to find the shortest path. So by using the shortest path only, we can able to transmit the data from source to destination. Okay, next is a routing algorithm classification. Here routing algorithm classification can be done in many ways, either global or decentralized information, or and then static or dynamic process. So here global means all routers have complete topology link cost information, link state algorithm. Okay, by using the link state algorithm only, the process can be transmitted from one node to another. And then by using decentralized means router knows physically connected neighbors, links cost to neighbors. So iterative process to computation, exchange of information with neighbors. Okay, so same way it is a process, iterative process means if for example if you are using a looping process in C language, if you are using a looping process means for example for I equal to 0, initial starting is value is starting value will be assigned as 0, and then I less than or equal to 10 means till the cyclic looping process will be end till I less than or equal to 10. So till that I less than or equal to 10, I plus plus. So till that one cycle is completed means this will incremented the value, I value will be incremented. Likewise, the iterating process will be executed in the distance vector algorithm. Okay, and then static means it routers change slowly over time based upon the routing algorithm is based upon IP address can be changed slowly. Okay, dynamic, if you are using dynamic routing algorithm means it can change the routing process quickly. Periodically update can be performed in the network. In the response will be performed easier in the particular network. So the routing algorithms are like link state, distance vector, and then hierarchical routing algorithm. And then here by using the internet, what are the algorithms are connected means RIP, OSPF, and then PGP. These three algorithms, these three types of algorithm can be executed and implemented by using the internet. And then these three algorithms, link state, distance vector, hierarchical, and all, by using the normal network only, the connected between the networks from source to destination only, the data can be transmitted from source to destination. So by using that only, these three algorithms are implemented. Okay. Next, a link state routing algorithm. The link state algorithm is also called as a Digistar's algorithm. Digistar's means here notation assigning C of x comma y equal to cost of from one node x to y. It's assigned as a first is not assigned as a infinity node. If not infinity means it directly goes to the next node. Okay. D of E, distance of vector, current value of cost of path from source to destination. For example, x is assigned as a source node, current value, that is from x to y. What is the value between x to y? What is the cost value between x to y? That is the path between the value, current value between to travel between the source to destination. And then P of V is a predecessor node along the path from source to V. Source to along the predecessor node means previous node which is assigned as a path node which from source to destination. And then N is assigned as a set of nodes whose least cost path definitely known. Okay, based upon this process only, the data can be transmitted from one point to another point, and also finding the least path, and then from node 1 to node n, finding the least path to reach the destination from source to destination. Okay, and then forwarding table means it is based upon the source node. It can be done with the help of source node, that can be forwarding the routing table between the source and the destination. See this example. Here the routing Digistar's algorithm has given initialization n equal to u for all nodes v vertices. V means vertices, and then if vertices adjacent to u means node, new node means then d of v, distance vector, equal to c of u comma v, vertice adjacent comma node. So based upon this condition, if condition is true means this will be executed, either else condition will be processed, else d of v equal to infinity. So here we are finding the d of w is a minimum, add w to n. W means here assigning the path between the from source to destination, where assigning the w is another node. This is a intermediate node which is connecting the source to destination. So here assigning as a u x v w x y z, and then here finding the shortest path to reach the destination. Here u is assigned as a source node, and then z is assigned as a destination. And then to travel from u to z means the cost will be from we are traveling from u to in the way u w v and then y and z finally. And then the cost to travel in this path means the value will be 12. If you travel in the another path means the cost will be higher. For example, if you are from u to x will be 5, and then from x to w will be 4. What if 5 plus 4 9, and then from w to directly y it goes to 8. To 9 plus 8 means 17. 17 plus 2 means 19. So by using another path means the cost value will be high. So by using the shortest cost value, shortest path tree, we are tracing the values from one node to another. So the values to travel from source to destination, which is assigned with the shortest path. Here starting node, first step will be assigned as a u, and then second step u comma w, and then third step we are adding u comma w comma x, and then in fourth step we are adding u comma w comma x comma v, and then in fourth step we are adding another node as a u comma w comma x comma v comma y, and then in fifth step we are adding z. So finally the 5 nodes, how we are finding the shortest path between the source to destination from starting node to ending node. Okay, this is algorithm is used to find the shortest path between the source to destination. See, in the algorithm complexity means it is used as a n nodes. Based upon n nodes, there will be each iteration will be from one node to another node. It is more possible of n log n. N log means number of nodes assigned in the log value. If based upon the n number of cycling process can be performed, or n number of new routing process is implemented. Okay, here initially we are assigning from C to D. Here one will be assigned as a from D to A to B, and then B to C. This is the one node, and then another node we are using another diagram. We are using we are connecting the all nodes B, A, B, C, D, and then third diagram we are using as a D to C, D to C to B, and then B to A. This is another path, and then finally another diagram we are finding the path as a to D, and then D to C, and then C to B. Okay, by using the within a 4 nodes, what are the types, what are the various ways, various routing process or routing path which is used to find the shortest path. We are going to find the shortest path only. Based upon that only, by using the shortest path only, we can able to transmit the data from source to destination. So with the help of this only, we can able to transmit the data. Okay, next algorithm is distance vector algorithm. Distance vector is implemented with the help of Bellman-Ford equation. It is dynamic programming. It is dynamic programming in the sense, let d of x of y equal to cost of least minus cost path from x to y. This first one is a cost of least minus cost least from x to y. So it is we are subtracting the least value, subtracting from that cost path from x to y. Then the value will be, the minimum value will be taken from that the cost value. So here we are assigning the cost of neighbors, cost of x comma v. Here x is assigned as a one node, next neighbor node. V is assigned as a neighbor node. For you, what are the, who are the neighbors means v and x are neighbors. For v, who are neighbors means w and x are neighbors. For w, who are neighbors means v, z and y, x. These are the neighbor node. So which are a node connected to the particular node, particular n node, which are all called as a neighbor node. So here we are clearly identifying dv of z equal to 5, dx of z equal to 3, dw of z equal to 3. Finally, we are finding the minimum of c of u comma v plus dv of z, and then c of u comma x plus dx of z, c of u comma w plus dw of z. And that in this finding 2 plus 5 comma 1 plus 3 comma 5 plus 3. So in this shortest value, minimum value is 4 is a minimum value. So we are find the value c of u comma x plus d of x comma z is a minimum value. Okay, by assigning the half value or shortest path, we are forwarding the packets between the from one node to another. Okay, here we are assigning the d of x of y equal to estimate of least cost from x to y. X maintains the distance vector d of x equal to dx of y is to y epsilon to n. So node x knows the cost of each neighbor. C of x comma v maintain its neighbors vector for each neighbor u comma x maintain dv of equal to dv of y epsilon n. The key idea: from time to time each node send its neighbor owned distance vector estimates its neighbor. So distance vector is estimated with the help of neighbor node. So we are counting the neighbors node with the minimum of each node. If for example x is assigned as a intermediate node, which are the neighbors are y and z. So we are finding the in that y and z which will be the minimum path, which is the minimum value to travel the destination. So under the natural condition, it has to establish the least value, least cost value. Okay, and then here we are seeing the each node wait for change in local link cost message from neighbors. So based upon that, the message from neighbors will be calculated till that the waiting process is implemented, and then recompute is estimates, recomputation process is implemented. If dv to any destination means has changed, notify to neighbors. So distance vector to particular any neighbors means it can be notified to the particular neighbors. So iterative means it will be cyclic process, or asynchronous means by updating the message to neighbors it will be asynchronous. It will be, and in the process of distributed means the neighbors will changes the distance vector, then notify it neighbors. By using the distance vector, the values will be changed, and then it will be notified to its neighbors. Okay, these are the process carried out the distance vector. By using this diagram, see, node of x table will be assigned node of y table and then node of z table. So we are using the x, y, z by using the which will be the minimum value. Here 2 c of x comma y plus dy of y comma c of x comma y plus dz of y. Then value is 2 plus 0 comma 7 plus 1 equal to final value is 2. So 2 is assigned as a minimum value. So another in this diagram, minimum value of c of x comma y comma plus dy of z. So where c of x comma z plus dz of z. So here minimum value is 2 plus 3 comma 7 plus 0, which will be the minimum value means 3 will be the minimum value. So the distance vector between the source to destination, the path between the source to destination will be the which is the minimum value. The total time duration between the x node to y node and then y node to z node, that is a total duration between the from one node to another node. There is a time duration between the one node to another node. Okay, this is a comparison between the link state and distance vector. Here first you are taking message complexity means link state means which nodes as a e links o of n of e edges message sent. By using the distance vector means exchange between neighbors only. Here by using the distance vector means the data can be shared within the neighbors only. Okay, and then speed of convergence means if you are using link state means algorithms requires o of n of e messages. It may be oscillation. Okay, the distance vector means conversion time varies, may be routing protocol, and then count to infinity problem. Okay, robustness means if you are using in the link state means nodes can advertise incorrect link cost. Each node computes only its own table. Each and every nodes by using that only the link state will be executed, and then link state will be executed between the path to path. Okay, and then by using the distance vector means the node can advertise incorrect path cost. So by error propagation through the network, if you have error between the one path to another path means there will be a error propagation through the network. So these are the difference between the link state and distance vector routing. And then third type is a hierarchical routing. Hierarchical routing in the sense it will be used as a 600 billion destination. Source will be one source, and then destination will be a 600 millions. Hierarchically it will be transmitted that data from source to destination will be transmitted to n number of destination through the routing table. Okay, here gateway router is assigned as a AS. AS means is assigned as a source node, or we can assign as a autonomous system. Based upon the autonomous system, there it will be automatically generated as a from one LAN to another LAN. You can say as a one autonomous system, two autonomous system. There will be a three autonomous system, which is assigned as a administrative autonomy. Internet equal to network of network. Based upon that, if you are equal to internet of by using internet, it is also called as a network to a network. So each network admin can use to want to control routing its own process between the one node to another. So here intra AS means intra autonomous system routing protocol is assigned as a different autonomous system can run in the intra AS routing protocol. Okay, here by using that different autonomous system, we are connecting that different autonomous system to intra autonomous system. So it is combined with that and then forwarding the routing table with one autonomous system to another autonomous system. These are the process to be carried in the hierarchical routing process. Here inter autonomous system task. What are the inter autonomous system means within a network how the data can be transmitted within an autonomous system, how we are transmitting the data from one source to another source. So we are assigning the one autonomous system means it is transmitting the data from one autonomous system to another system. It determines the routing table and then finding the path which is assigning a least path to travel from source to destination. So it is finding after finding the least path, after that only the data will be transmitted from source to destination. This is the inter autonomous system task. Okay, same way intra autonomous system task means it is also known as interior gateway protocol, which is used as a interior process which is used in the internal process, commonly used in the intra autonomous system routing protocol. It can be divided into three types: RIP, routing information protocol, and then open shortest path first, and then IGRP. IGRP means interior gateway routing protocol. It's a Cisco property. Okay, by using RIP, we are traveling W, X, Y, and Z are node. A router are A, B, C, D, and E are routers. So we are traveling from one router to another router means it is assigning for a subnet W. Router is W. From W to what is a node or router is connected, A is connected. From Y, what is a node is connected to Y. Y is from a previous node is a B, and then next will be a router. So B is assigned as a previous neighbor node, and then X is assigned as a and then the next node. So by using the B node, it is a hop process will be performed. And then Z, for Z there will be a B node by same B node which is connected to the which is connected to the routing table of router D. So by using D, it will be travel from one hop to another hop. So it is an example of routing information protocol. Based upon this only, the data can be transmitted from source to destination by using the next hop process. Here next is RIP. RIP means routing information protocol, which includes a BSD Unix distribution in 1982. It is a form of a distance vector algorithm, which is can be used, a maximum limit can be used as a 15 hops. By using the distance vector, it can be interchanged every 30 seconds in response message advertisement. So each advertisement can list the number of destination and then subnet address. Based upon that, the data can be transmitted from source to destination. Here subnet are assigned as a U, V, W, X and Y and Z. And then hops, you are using the hops is from U node to particular node A is assigned as a one hop. From E node, from U to A one hop, and then from A to V is assigned as a another hop. So it is assigned as a two hops. For W it's assigned as a U to W, U to A, and then from A to B it is with the help of V it is assigned also two hops. So by using two hops it can be transmitted from source to destination. Here link failure, if any link failure is occurs means there is no advertisement heard about after 180 seconds. If neighbor nodes his link is affected means by using that routing protocol it is declared link is declared as a failure or link is declared as a dead node. So routes via neighbors is invalid. By using the router it will find the shortest path or what are the problem occurs in the routing process, the new advertisement sell to the neighbors. So neighbors in turn somehow send out a new advertisement if table changed. If a routing table has changed means the new routing table process will be transmitted from source to destination. Okay, the link failure information quickly means link failure in the particular process means it will propagate the entire net. Okay, the position reverse, Poisson reverse means it can be processed to prevent ping process which can be transmitted from upper layer to lower layer. So here upper layer for a network layer, what is the upper layer means transport layer will be used as a upper layer that will be forwarding the table, routing table will be forwarded to the upper layer. So from next is a data link layer, finally it is assigned as a physical layer, and then from the destination side also there will be a routed which is forwarded the UDP packets from network to IP to transport layer, that is a UDP protocol. So forwarding tables is assigned as a also assigned as a node which is to be connected from other node. Based upon that only the table will be routing table is generated between the source and destination. Okay, up to this routing information protocol is over. Up to this you have any doubt? OSPF we will discuss in next class. Do you have any doubt up to this RIP? RIP, you have any doubt? We have discussed about today topic is link state vector, discharge algorithm, hierarchical routing. In the hierarchical routing, inter autonomous system and then intra autonomous system, how the hierarchical routing process is implemented, and then over the internet what are the three algorithms RIP, OSPF and then BGP. In this three algorithms we have discussed about RIP. Okay, up to RIP we have discussed today class. You have any doubt? You have any doubt means tell me. This is an important question. Like OSI model, this question is important. Your second assessment exam will be scheduled on 28th. Starting exam will be scheduled on 28th this month. Second cycle test 2, CAI 2. The portion for CAI 2 is unit 2 and unit 3. Okay. This is an important question. You have any doubt means tell me. You have no doubts. Okay. I will stop sharing my screen. Okay. Thank you to all. Thank you.